Hey, I'm Rob, and I'm the head rocket engineer for this project.
And I'm Notarios, and I painted the rocket.
Wait, but we didn't paint the rocket.
Well, it's not my fault that the egg didn't survive.
The purpose of this project was to design and build a rocket in a mere 4 hours that would fly to about 1,000 feet and return an egg that was attached to the nose cone intact.
This is a quick procedure of how we designed and built our rocket.
We started with our rocket fin design. We compared different fin designs including the tapered swept, the delta, and the trapezoidal. We decided that the tapered swept design would provide the best aerodynamic and aesthetic qualities. In addition, we trimmed the bottom of the fin into an arc shape in order to reduce excess weight.
In our payload, we cut a hole and inserted the high-definition camera inside. We secured it by gluing a foam piece over it. For the part of the camera that was sticking out, we used tape and attached it closer to the nose cone. The slope provided better aerodynamics and thus reduced drag. Put dotted lines to separate the rocket. Measured the diameter and marked important points. Built a motor and attached it. Glued the fins on the rocket.
Built and attached the balsa stopper. Attached a shock cord and made a parachute. Secured them inside the rocket. Reattached the payload. Attached the launch lugs. We are now ready for launch. What's the worst thing that could happen?
When your
Fins!
don't work like they used to before.
Since our fins broke, we used glue and tape to reattach them. We took advice from Dr. Gabel on how to secure the egg.
If you want, you can give you a pair of scissors and make a hole in there if you want to get rid of the air. You need to make sure that the
3, 2, 1, 0.
A few moments later.
Our rocket reached a maximum altitude of 828 feet within 8 seconds of launch. As we can see from the graph, the rocket takes more than 8 seconds to come back to ground level. This is due to the air resistance given by the parachute after it has been deployed. Also, it is worth noting that the slope of the trajectory curve after reaching a maximum altitude is approximately negative 30 feet per second for the rest of the flight. Due to this constant slope of a position versus time graph, this means that the velocity of the rocket parachute system reaches a constant velocity, otherwise called the terminal velocity.
Our rocket reached the maximum velocity of 300 feet per second about 2 seconds after launch. The velocity quickly decreased and had a constant rate of change from second 4 to 8. When it reached its highest altitude, at second 8, it fell at a constant velocity of about minus 30 feet per second until impact. This is similar to the thrust versus time graph from the experiment performed outside of Talbot, where thrust quickly rose and fell in the manner shown in the graph.
At the end of the day, our rocket reached an altitude of 828 feet, 272 feet short of our goal. Also, our egg did not survive. Our second fin broke and our rocket was determined to be unusable after landing.
Improvements that we could have made include creating bigger fins, a CAD part that would protect the camera, and a safer way to transport the rocket so that our fin wouldn't break.
In this project, we learned about the different fin designs, the process of creating a model rocket, and the relationships between different forces and variables.
See? I did paint the rocket.